Today, we're going to be hearing from Ashot, who is a co-founder and partner at SmartGateVC, a Glendale-based pre-seed VC firm focused on providing early investments in science-driven companies. I remember meeting Ashot actually when he came here, and we started chatting, and he's like, I think that would be a really interesting place for me to present. And I said, let's sign you up. And that seemed a long time ago, and here we are. So really happy to have him. We haven't had a VC here for the last, I don't know, few months. So it's been a while. So really excited to hear from you, Ashot, and hearing your insights and your knowledge about some things that you've learned and things that you're doing. So please welcome Ashot onto the stage.
Thank you. It's a pleasure to be here, and time flies indeed. I think it was probably a few months already back, right? Yeah. So really a pleasure to be here and talk to you very briefly about myself. I'm co-founder and partner at SmartGateVC. A
little bit closer to the mic. You have to talk over.
Later?
Yes.
Yeah, good. Okay. So I'm co-founder partner at SmartGateVC. We are focusing on pre-seed and seed investments. We have done 31 investments since 2018, and more than half of those investments we were the first investor. So, and many of the companies were incorporated right next to us. So we helped throughout the incorporation process and everything else. So we are really a VC firm that is happy to get into work with the founders very early when it's too early for other VCs. And what we are focused on, traditionally, we're investing in the AI space, and now we are harvesting some of the good results with the AI wave. Today, we are investing in the areas that we believe will be the next wave that is going to be unleashed by AI, which is brain-computer interfaces, AI and physical world link, or edge intelligence, and unprecedented challenges in cybersecurity that are coming with large language models. Myself, I'm PhD in economics. So as you can see, it's not technical in a sense, but I have been in deep tech investing last 10 plus years. So what I can say throughout this experience, it was a learning path of connecting the dots. So how we connect science, entrepreneurship, and how we create businesses in very innovative areas. So before I continue, I'd like to ask the audience, do we have scientists here? PhDs, postdocs, professors? Okay, nice. And are you entrepreneurs as well, or focused more on the science part of things? Okay. Yeah. So, okay. And do we have people from technology transfer departments, or people related to helping scientists to build companies, whether in legal space, whether in other capacities, CROs? Okay. We don't have many, but generally, my talk is an address to a scientist who is building a company. So I will kind of reshuffle it to the audience, but think of it from the other perspective. What it takes for the scientists to build a company, what are the challenges there, and how we basically convert science into companies. So uh, let's think about deep tech entrepreneurship. This is really very interesting times we are living right now. If you have encountered the venture capital space, if someone is doing hardware in business, usually 90% of venture capital funds go out. Like, this is hardware. We have nothing to do with this. If something is deep tech, a lot of venture capital funds will say, oh, like, we don't want to deal with this. This is too complicated. This is capital intensive, etc., etc. But some things, some trends are happening right now that will fundamentally change how things work in the VC space. First of all, think of the following. The artificial intelligence is now in our everyday life, right? So if you look at it, almost any email or whatever we do in the digital space, it's somehow interacting with GPT or Claude or some other large language model. It's already part of our lives, but it's only part of our digital lives. So devices around us, the whole industries that operate in the physical world, they are untouched by AI just yet. So everything that connects artificial intelligence to our physical world is yet to be unveiled. And you can't do that in the software world. This is only possible if you involve in that process also hardware. And you need teams that are very good on the software side and very good on the hardware side simultaneously. So this is very interesting thing that next 5 years will shape a lot what we are seeing in the technology domain. Then think of it from the other perspective. It's not peaceful time these days. Like, there are wars here and there. We hear a lot of scarcity of technologies and weapons, etc., etc. This is the bad side of things. But let us think of also the positive side of things. There is an unprecedented amount of spending on different non-dilutive fundings from Department of Defense, Department of Energy, other areas. And this is going to unveil another opportunity of technologies that lack the last mile. So right now, a lot of things in hardware and physical space that are very capital intensive, it's not feasible for venture capital to invest there because it's simply commercially not feasible. But given the volume of non-dilutive funding coming to this area, at some point, the last mile of venture capital will come and reshape this and get these technologies to our everyday life beyond any defense or military use cases. This is something that happened in the past. This is something that is going to happen in the near future. So think of it this way, hardware will be back. But this is not only about hardware. If you think about life sciences, if you think about any other like material sciences, everything is going to be disrupted since there is this good ripeness of disruption and new modes of innovation here. So it's a very exciting time for someone to do deep tech entrepreneurship, for scientists to think about starting ventures. But these exciting things come with their own challenges. But before we go there to the challenges and the building blocks, let's take a look. What are the building blocks of deep tech entrepreneurship or science-driven entrepreneurship? From the perspective of science or of company building, when we say science, we mean IP, intellectual property. So if you want to publish, if you want to be like have academic glory, this is different thing. When we talk about entrepreneurship, it's about monopoly. So where is it that you can have something that others can't have, and you can build technology based on that? So from that perspective, it's either patents or trade secrets, right? So patents are things that are public, belong to you. Trade secrets are those that are not public, only you know about those, and you don't want others to know about it, and you can utilize those. In terms of risks and benefits, patents basically can be replicated, but you can enforce, right? So as the owner, trade secrets, if someone does the same thing, you can pursue that, litigate or something. But you assume that it's very difficult to come up with the methods and technologies that you have. That's why you keep it in the secret. But this is what is valued in deep tech entrepreneurship. But the other part of it is execution. And this is the most undervalued part in entrepreneurship. And execution is very important. Think of it, first of all, prioritizing. So for strategy, what are we doing? Where are our priorities? What we build first and how we continue. Fundraising, another huge challenge. Organizing, hiring, selling, all these activities along the way of the company building is crucial. And usually there is a fundamental lack in academic circles in this of skill set in academics circles for this. And if you think of what means business or company building from, as we say, from great science to great companies, it's intellectual property multiplied by execution. And it's very important. It's not additive, it's not plus. Because if execution is zero, the result is zero. If IP is zero, the result is zero. If both are powerful, the result is like exponential. So it's very important. It's not additive. And therefore, it's very important when we talk about science-driven entrepreneurship to put an emphasis on the both parts and make sure that the system as a whole develops holistically. It's very important also to understand if as a scientist, someone wants to go this journey of entrepreneurship, is it really for you? So is it something that as a scientist you would like to go? You know, in academia, there is very important areas of strategizing and selling all the time. It's not that in academia you just sit down and like everything is perfect, right? So those who are in academia right now, they will say there is a lot of internal politics, there are a lot of external politics, a lot of very important science, strategic questions in the science. So how you dominate a scientific field, how you organize your postdocs, let's say if you are a professor, so that you cover a whole field and let's say become top 5 in the United States, nationwide, in that particular area. So these are really strategic questions. They involve a lot of strategic thinking. You need to sell yourself. Grant writing, it's a huge kind of area domain of its own with a lot of expertise that you need, a lot of knowledge that you need, and scientists do this all the time. So there is a lot of this, but industry is a whole another game. So, and it's you as a scientist, you need to get out of your comfort zone when you go to build a company. It's not anymore those things where you kind of fish in the water, you know every other area like how to navigate there. No, it's a whole new area that you have to learn to navigate. And for scientists, it's really a challenging place. And it's a question, first of all, do I, as a scientist, want to go that route? And if the answer is yes, there are two kind of modes, or let's say if we look at the continuum of venture building, science-driven venture building, it's two extremes are one, a studio model or incubator model, where a scientist basically is hired by an investor or venture capital infrastructure. They have their salary, they have their life, and you basically concentrate on the science, and every other piece around execution is organized by the investor. So in a way, it's a different type of your university work. So scientists who used to work at a university, now they work at a company that belongs to the investor mostly, and they still have their creativity, but it's less academic. There is less white for that, and it's more into the depth of the particular topic and particular milestones. The other end of this continuum is the warrior mode, where you have to take care of you take care of your destiny, basically. So how you build a company, how you go to the investors, how you strategize, how you over all the mistakes that you are going to make. So all this is on you. If you think of some examples, everyone knows Moderna, right? Which is due to COVID, many of us know. But Moderna comes out from Flagship Pioneering, which is an incubator type of company, multi-billion, in many IPOs, attraction of many IPOs, etc. So what they do, you have an interesting science, you come to them, or they have an interesting hypothesis around certain area. They find the scientist, they build a company, they bring in the CEO, they fund it up until Series C usually, which is until like 100+ million. And then they open it for external investors, etc., then IPO and the other stuff. And the other edge is where, again, as a professor, as a scientist, postdoc, whatever, you take care of your destiny. Now, here, again, the part of venture building, like flagship model, it's apparent, right? So it's not too much to talk about it. But when it comes to the warriors who are building their companies, so here we need to dive a bit deeper. So there's three main phases of building. One is the phase of building IP. What happens here is you are as scientists in the university working on a specific technology, not probably initially even knowing its value, etc. At some point, the potential commercial value is realized. And there are grants coming, non-dilutive funding, university funding. So the scientist is on the payroll of the university and the company is being built. Then the spin-off stage comes. It's at the stage when you know more realistically, it's very inefficient to be within university because university is slow. It's a big bureaucratic institution. Any university is slow, right? So you can faster decisions with faster capital coming your way, building things. So when the moment when you feel that being outside of university is more beneficial to your progress than being inside university, here is the spin-off part. So you license out your technology from the university, you raise the first capital, and you continue your research and development outside the university. And the third phase is basically scaling. And scaling is, you think of it when it's lesser on the focus on the research and more focus on the development. So the research part is always there. If it's a science-driven company, you always research. But it's more about development of the technology towards the milestones, products, etc., depending on the type of the product you have. And the most important thing, if you think of these phases, it's all about how you nurture your network. Think of it, there's a very nice saying, you are the average of 5 people with whom you spend most of your time. So it's very important how you nurture your network throughout these phases. This is the crucial thing. And think of it the following way. In the phase of IP, and remember, execution is another key component, right? So you are, as a scientist is very powerful on the science side, and the weak part is the execution side. So all you need to do from the day zero to build up a network for the execution. So when the time comes, you are capable of executing the company. So what you do at the IP stage, you go out. You go out and meet people, potential future executives, future advisors, talk to them, get people know about this. Second stage, spin-off. The executives you met in the previous stage come as advisors. So you don't hire them full time, but these are people who are already on board with you, and you work together to around your company building. Third phase, some of these executives come as a full-time team members. So you raise the round, you hire them, they come on board, they make the execution machine. So the venture building process of a science-driven company is on this. If we look at this from this side of things, it's a story of building a network of people and integrating these people in your company, in your way, in your path. This is I call these people godfathers, and let me tell what I mean. As a scientist, then again, you have fundamental scarcity of skills in execution. You don't know investors as well as you should. You don't know uh, people in the industry as well as you should in order to sell, in order to raise, in order to do anything else. And it takes time. Like it's very much relationship driven business. Why? Because it's trust based. Investment is first of all about trust, right? Uh, Doing any contract is first of all about trust. Trust comes with attraction. Trust comes with history of relationships. So how you build these relationships, being a first-time founder, it's very difficult. It's very time-consuming. So in many successful cases from our own experience and others in the industry, is when these teams find those godfathers, as we call, that come on board and bring all their rich history of relationships, network to the company. And now if you, let's say, need 10, 20, $30 million raise, which is practically impossible for you because even the science, etc., looks very interesting, but are you capable of just absorbing this amount and spending in the right way, etc.? Do you have the skill set? These are questions, and there is no. It's very difficult to get the full trust of an investor for that capital. But now these kind of godfathers or CEOs whom you get on board, these people come to complement your skill set and help you build a company. And again, how you get these people? You go out, you talk to people, you nurture the relationship, and at some point you find this ideal candidate. Another area to talk about is uh, basically the strategy, but uh, let's talk about from different phase perspective. So there is two parts of this. In the initial stages, when we talk about strategy, we talk about research and development strategy. So how you build your science, how you build your research, uh, tuned towards the successful company. And then later, it's all about go-to-market. So how you take what you build to take it to the market and get the traction in the market. But in whatever phase you are, it's very important to think about minimum viable milestones. A lot of us know about minimum viable product, right? So what is minimum viable product? Something that works, right? You can put in front of a customer, they try it, it works, it's viable, so it's not that they will continue using it, and you can build upon that. But the concept of minimum viable milestones is equally important. What are the milestones that you need to achieve with the current funding or the current stage phase that you are in so that you can get to your next level? Because what happens, let's say, if you don't, if let's say in life sciences, if you don't get a clinical trial positive result in therapeutics, you can't go to the next level, right? So if you raise something that is not sufficient for you to complete the clinical trial, you are nowhere. So it's like you jump, but you don't have the stamina to get to the end, so you fall in between. And it's very difficult then to raise the additional capital. So it's very important to think, what are the milestones that we want to focus on for each stage of our development, and think of the process from the milestone standpoint. Some other useful tips to think about, and which are usually missed, and not only science-driven entrepreneurship, but any entrepreneurship, like involve the right lawyers. You mentioned Wilson Sonsini as a sponsor. I know them very well, and Kenji, who is partner based locally. Yeah, they work perfectly in negotiating with universities together with the founders on different terms of license, etc. Don't leave it just on your luck and destiny. Also, have your own lawyer versus university lawyers to do your patents, etc. So this is very important. Make sure advisors work. A lot of advisors like to be optical advisors. So just you put them on the deck to say, oh, I have this advisor, these guys there. But if they don't work, that's not very useful for you. So if you have a great science, then it deserves some work by your advisors, ideally also some cash investment, by the way. So make them work. Make sure when they sign up to help you, it is actually not for optics alone, but also doing some work. Postdocs. If you look at the statistics, only 10 to 30% of PhD graduates eventually get positions in academia. So we have a lot of people, very trained, very skilled, that actually won't get any position, but they have the science knowledge of the science, sometimes very good ambition to do something. So it's a very good resource to leverage when thinking about venture building. Beware of people who don't trust. This is very fundamental, I think, in life in general, but also in entrepreneurship particularly. People who don't trust you, they are not good partner for you. So everywhere you go forward, be surrounded by people who trust in you and what you do, and nurture that trust from your end. And also beware of people who suck your energy instead of inspiring you. Energy, creative energy in our lives is the most important thing that drives every other thing that we do. So we need people around us that inspire us, that help us go forward versus criticize or convince that what we do makes no sense, right? So constructive feedback is always good. I'm not talking that we need people who just say, oh, you're great regardless of what you are doing. Constructive feedback is good, but we need people who are constructive and inspiring around us. A bit about investors. So we have Yeah, finishing. We have usually there are two types of investors. Like again, if you look at the continuum, there is this Bay Area investors or Silicon Valley style investors, driven by vision and inspired by disruption and all the nice cases that we see. And let's call other, or sometimes they call East Coast style investors, who are driven by details. They will go into different details to try to find what's wrong there. Will drive to different details on agreements, private equity style, like it's private equity but small. So again, ideally you want Bay Area style investors. Like we don't have offices in Silicon Valley, but SmartGateVC, we always say we are a Silicon Valley fund. Not because we have presence there, but because the spirit that we follow as a venture capital fund is this one. Know your exit strategy. So VCs sell jet fuel, and it's a problem when VCs try to sell their fuel on a bike owner, or the bike owner thinks they can fly. So not every IP, not every science, not every technology is something that is going to fly, even though it's very good. Like there are very cool bikes, just great things with their funds, but they are not jets. So you need to know your exit strategy, the magnitude of the venture that you are starting, and it needs its own capital structure. Sometimes maybe it's not even a venture, maybe it's just an IP that you need to license, get the royalties, and that's it. So you need to think about the exit strategy from the very beginning. Yeah, and there are like 70,000 roughly jets and 700 million bikes. Yeah, and finally, I want to share this quote. I love it a lot by President Kennedy about going to moon. It was really an ambitious target back then, but as he said, we are doing this not because this is easy, but because it's hard. So deep tech entrepreneurship is not easy. It's hard. It comes with a lot of challenges, but it's really exciting. And the results that you see affect our daily lives from anything that we do, physically, in our health, in our mm, mental capacity, anything. So it's the results are exciting, and really, if someone is in deep tech entrepreneurship, this is great endeavor, and wishing all the good luck there. So thank you. Uh, Thank you. Yeah, this is, you can connect me on LinkedIn. Happy to keep in touch.